What up, geometry students? How we doing? We got some questions about quadrilaterals. What is a quadrilateral? Hope we know that. Quadrilateral is just a four-sided shape. So I think that was a question some of my students have. They're like, "What the? Wait, what are we talking about? What the heck is a quadrilateral?" All right, thing is bugging out. Come on. That's so sad. This is like my go-to slate that doesn't want to work. Okay. Four-sided shape. Here's our four-sided shape right here. This looks like we have a parallelogram. We can't assume it's a rhombus. Rhombuses are parallelograms with all equal sides. What we find is every single opposite angle will have to equal, and we have to also see that they're supplementary to each other. So this is 120, this is 60. That's good. So it's cool to see that. I don't think I even mentioned that in class, my first class. I'll mention it the next class. Cool. There you go. A circle with a radius of 8 is created. So here's a circle, and the radius is 8. So that means all of the lengths from the center to the outside is 8. Means if we go across through the center, we have 16. 2 points of the circle are drawn. Visualize the circle created. Okay. Or maybe the triangle. Yeah, okay. Visualizing the circle. If those 2 points and the center are connected, what type of triangle must be created? Ah. Well, since we have a radius of 8, the 2 points on the circle with the center must have lengths of 8, which means we don't know that it's an equilateral triangle because I could put these 2 points anywhere, but I do know that it does have to be an isosceles triangle. So let's say I put the point here and point there. Obviously, um, these are points more opposite of each other, so like further away from each other. Um, you can imagine the third side length being different than 8. So it's an isosceles triangle. Can a rhombus be created from your circle? Yes, I can create a parallel line to this line going through this point, and a parallel line to this line going through this point. And would that ensure this distance would be like the same? That would ensure this is 8 and this would be 8. So I'm saying yes with parallel lines. Provided we have this, provided we have the circle started and the intersections of the two parallel lines would end up, kind of recreating the circle with the idea of our lengths being the same. Cool. Two equilateral triangles share one side. What type of shape is created? Okay, this is an interesting thought process. Okay, so this is 60. This would have to be 120. This would have to be 120. This would have to be 60. All of the side lengths are the same. I must have created a rhombus. A rhombus is a quadrilateral. All sides are the same, but the angles are not the same. The opposite angles will be the same. Cool. Two right isosceles triangles share their longest side. Okay, so here's a right isosceles triangle I'm thinking of where the two side lengths are the same and I have a right angle. And if I share the same side, well, that means that these side lengths have to also be the same if it's sharing the longest side. It looks like I've just created a square. That's fun. What type of triangle, when sharing its longest side with a same size copy of itself, makes a rectangle but not a square? So rectangles have four 90-degree angles. However, the side lengths are the same. Well, I can kind of tell just by connecting two of the corners of a rectangle. It's almost like start with a rectangle. That a right triangle, not an isosceles right, but a right triangle, copied and placed on itself would make a rectangle. Cool. All right, a quadrilateral is created so that two parallel lines are intersected by one transverse that is perpendicular to the two parallel lines. Okay, so when I cross the two parallel lines with one perpendicular transverse, I've created 90-degree angles. That's what perpendicular means. And one transverse line that makes a 7-degree acute angle with the parallel lines. So that means this acute angle is 70 degrees. Visualize or sketch the diagram. What are the four angles of the quadrilateral? Well, I'll have 90, 90. I'll have a 70. And then I must have the complementary angle 110. Okay, that's good. So two 90s, a 70, and a 110. Quadrilateral is created. The four angles of the quadrilateral are equal to a number, twice that number, three times that number, and four times the number. What is a number? All right, well, I'm going to say that the number is x. So I'm going to say one angle is x, the other angle is 2x, the third angle is 3x, and the fourth angle is 4x. So what's the key to quadrilaterals? Well, quadrilateral is created from connecting two triangles. Triangles angles add up to be 180. Add up two triangles, we get 360. So x plus 2x plus 3x plus 4x equals 360. 4, 5, 6, 7, 8, 9, 10 x's equal 360. So that means my number has to be 10, which means my angles are 10, 20, 30, and 40. No. 100? 36. Oh my gosh, it's not 10. 360 divided by 10 is 36. That doesn't make sense. Okay, now that makes sense. So my angles are 36, 72, 98, and 130 something. 134. 134. I think that's right. Mental math. Tough. A quadrilateral is created. The four. Oh, I gotta take this in case my kids are in trouble. No, telemarketer. We're good. I'm flying solo. My wife's out of town. Going to Washington State to hike parks with her brother. So solo dad. Got to be ready for the phone calls. Four angles are A, B, C, D. A, B, C, D. I love how you guys were doing these problems in class. So I'm going to try to do it like this because I think it was just very smart and it's a very easy way to do substitution if you think about this. Okay. So here we go. Angle B is double angle A. So I'm going to say angle A is X. Cool. Angle B must be double X. Angle C is double angle B. Oh, well, if B is 2x, then C is 4x. Angle D is double angle C. If angle C is 4x, angle D is 8x. I really like how that's done. It's very intuitive. I think the way I was doing it on the triangles was very more mathematical with like equations and like substituting with equations. I really think this is an easier way to do it. So I like it. Good job on you guys for like influencing me and how I do things. Those four angles add up to equal 360. So that's 8x's, 12x's, 14x's, 15x's equal 360. If I take 360 and divide it by 15, I don't know what that is. 24. It's like so crazy how the numbers are just are cool like that. 24. What are the measurements of the four angles? Well, 24, 48. Double that. 96. Double that. 192. And it should work out that 24 plus 48 plus 96 plus 192 is 360. Cool. A quadrilateral is created. The four angles of the quadrilateral, or MNOP. So MNOP. Don't assume anything is right. And let's do it the way you guys were doing it, which is like really nice. Angle N is 10 more than double angle M. I'm going to say angle M is X. Angle N is 10 more than double X. Cool. Angle O is 20 more than quadruple angle N. Okay. So I need to quadruple angle N. I'm going to quadruple 10 plus 2x and then add 20. Well, that's going to be like 8x plus 40 plus 20. You could quadruple 10 plus 2x and get 40 plus 8x. So 40 plus 20 is 60 plus 8x. Cool. Angle P is half angle O. Well, if angle O is 60 plus 8x, angle P has to be 30 plus 4x. I mean, I just think this is really, really intuitive and smart. And you guys actually showed me this, and it was not how I did it on the triangle problem. So we have x, 10 plus 2x, 60 plus 8x, 20 more than quadruple angle N. P is half of angle O. That's just like great. So that means I have 1, 2, 3, 4, 5, 6, 10 x's. That works out nicely. I have 10 plus 60 is 70 plus 30 is 100, which means 10x has to equal 260, which means x is 26. And that's angle M. And for fun, I'm going to figure out the other angles. So 26 times 2 is 52 times plus 10 is 62. 26 times 8 plus 60 is 268. Then half of that is 134. Does this work out? 26 plus 62 plus 134 plus 268. Something happened. I made a mistake. $62. Angle O is 20 more than quadruple. Angle P is half angle O. Okay. I mean, I feel like this works out. Unless I made a mistake up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 60, 30, 100. 260 divided by 10. It's 26. Okay, so C should have 26 plus 62 plus 268. Yeah, this is not working out. Why is this not working out? What did I do wrong? N is 10 more than double angle N. Angle O is 20 more than quadruple angle N. So 40 plus 8x plus 20. Okay, so 60 plus 8x. Angle P is half angle O, so that's got to be 30 plus 4x. X 10 plus 2x, 60 plus 8x. Goodness gracious. Whoever's listening to this right now, I apologize profusely. Well, this shows you like math teachers, even they can make mistakes. Well, this is why we check, and this is why, I'm not ashamed to make a huge error there. It happens, just like check your work, make sure it works out. And if it doesn't, something went wrong. 12, 13, 14, 15 x's plus 100 equals 36, 360. 15 x's equals 260. Let's take 260 and divide it by 15. And I get 17.33333. So that's not a nice number. So I'm going to leave it as 260 over 15, which can be simplified by dividing by 5s to be 52 thirds. Cool. If I had like a Desmos calculator, we could make it work. I'm going to do it really quickly just to show it. Okay, so we're going to say x equals 52 thirds. X plus, what's 10 plus 2x? 10 plus 2x is, maybe we want to do b equals 44.6666. 60 plus 8 times 52 thirds. 30 plus 4 times 52 thirds. So I have 17 and a third, 44 and 2 thirds, 198 and 2 thirds, and 99 and a third. And I will add all these things together. So 52 thirds plus that, plus that, plus that. Yep, 360. Fun. Good question. Good finish. See you out there. Peace. Tests coming up next week, Thursday and Friday. Test next Thursday and Friday.